My name's Misha.
I'm Anna.
I'm Julia.
My name is Claire.
My name is Danushka. Our troop number is 62768 Space Cookies, and we are on Council Girl Scouts of Northern California. We are part of an all-girls Girl Scout troop and Bex robotics team from sunny Northern California. We want to welcome all girls from the country and the world to learn about robotics and to help you to earn your robotics badges. Today, you will be completing 2 activities to earn the Ambassador Programming Robotics badge. First, you will write a program for a robot to navigate through a paper maze. You will then write a program for a robot to navigate through any maze.
It will take approximately 60 minutes to complete the activities. The materials that are needed are Robot Maze 1 and Robot Maze 2, as well as a chess piece, checker, or other robot stand-ins, a pen or pencil, and paper. This activity doesn't require a lot of space. You can do this on your kitchen table, a desk, or on a coffee table, as long as you have a place to write. Let's get started on our first activity.
For part 1, we're going to write a program using regular language for a robot to solve the maze on this Robot Maze 1 handout. This activity will take no longer than 15 minutes. All you're going to need is your Robot Maze 1 handout and a pencil or pen with any extra sheets of paper you might need, although you can just use the second page of your handout to write on. Pause the video here to go gather your things. A computer program like this is a type of algorithm, a set of step-by-step instructions. Computer programs use commands to tell the machine what to do. A command is one step in a program. Computer programs are written in a type of code that can be understood by machines. For this activity, there's no specification for language, so you can just use simple commands like forwards, backwards, left, and right. Now we're ready to write a program that tells a robot how to follow the black lines to solve the maze. To start, we might write, go forwards 4 boxes, and the next line can be turn left, so on and so forth. After finishing the program, you can have a parent or sibling try to follow the steps. If they can get through the maze, your program works. Here are some questions to think about as you're doing this activity or after you finish it. What did you enjoy about this activity? Is there anything you found challenging or that you struggled with? As a challenge, find a map of a hiking trail and write a program for your robot to travel it. Pause the video here and take your time to go through each step of the activity, then come back for part 2.
For part 2 of our activity, we will be writing a program that can be used for any maze. But first, let's learn about some concepts that will help us create this program. When programming with any computer language, it's important to get the syntax exactly right. Syntax is a set of rules that is followed by any programming language. It includes spelling, spacing, symbols, and punctuation. Below is an example of code with correct syntax. To write a program without worrying about syntax, programmers often use pseudocode. Pseudocode uses commands in regular human language. Programmers then translate it into any kind of computer language. The only rule for pseudocode is that it should be easy to understand. Please pause the video here and take a look and understand page 1 and 2 of Robot Maze 2 handout to learn about conditionals, loops, and functions. Now, let's get started on creating a pseudocode program that can be used for any maze. It will take approximately 45 minutes with 5 minutes of prep time and 5 minutes of cleanup time. Here are the materials that you will need. Robot Maze handout printed out, any sort of stand-in for the robot. It could be a chess piece or a checker piece. In this case, we have Captain America. Pen or a pencil, and any extra sheets of paper you might need. Make sure to pause the video here and grab these materials before starting the activity. To teach the robot what to do, here's the rule. Always turn left if you can. If you cannot turn left, go straight. If you cannot turn left or go straight, then turn right. If you cannot turn left, go straight, or turn right, then turn around because you must be at a dead end. Now, translate the left hand on the wall method on page 3 of the handout into pseudocode. The pseudocode you will write might be pretty similar to how it is written in the rule, since the only rule for pseudocode is that it should be easy to understand. This program is often used for maze-solving robots. The rule is based on the idea that if you're walking through the maze and always keep the same hand on the same wall, you'll eventually end up at the exit. Now that we know how to use conditionals and loops, let's do a little practice with this maze, so that we know how to use them when we write our program. We will start with the function name, maze, and then begin our loop, and until the robot reaches the end of the maze. Then, inside the loop, we will tell the robot to go forward, and if the robot can turn left, then it will turn left. Else, and from here, you have to figure out what to write next. Be sure to use conditionals, loops, and functions. If we test the code we have so far with this robot, it can get the robot to go straight, turn left, straight, turn left, and go straight again. But after that, the robot does not know what to do. So now you have to write the rest of the code so that the robot will be able to get to the end of the maze. When we write a program, sometimes we run into problems. To fix the problems, we retrace our steps and see where we went wrong. We retrace our steps using an engineering notebook, where we have documented all of our processes. Once we have fixed the problem, we test it again and keep going. This process is called debugging. While you are finishing up the activity, start thinking about some of these questions. What did you find challenging while coding this program? What would you do differently next time? If you were to teach this lesson to someone else, what would you change? What are other ways to demonstrate the maze? What is something you would like to learn more about? Once you're done with that, if you are looking for a challenge, try writing pseudocode with conditional statements, loops, and functions to create a program that makes a robot follow the turns of a line. Good luck!
Today we learned that programming consists of commands given to a computer in order for it to carry out certain tasks. There are shortcuts used while programming called loops and functions. We also learned about pseudocode, which is a way to simplify commands so they're easier to understand. In Activity 1, we gave the robot specific commands for what to do. In Activity 2, we taught the robot how to go through any maze with one consistent command, instead of going through it step by step. This activity shows how computers understand different commands to complete a task. Programming is essential in robotics because it provides a communication between humans and robots. Without it, the robot wouldn't be able to complete any of its tasks. Once you've completed the mazes, it would be a great idea for you to think about these questions. What did you learn? What surprised you? What would you like to learn more about? And what could you share with your friends and family?
We hope you enjoy doing these activities as you earn your Girl Scout Ambassador Robotics badges. Maybe you'll get inspired to form your own robotics team or join one in your community so you can build and compete with your own robot. If you want to try coding a virtual robot, visit vr.vex.com. If you or someone you know are a senior Girl Scout, be sure to check out our other video. Please visit Girl Scouts at Home at girlscouts.org, check in with your local council, or reach out to us here at gsnorcal.org for more ideas. Thanks for watching!